Good morning, students. Welcome to this design and problem session number 4 in the design of screw threads. So let us begin with the session. So in the previous session, we have discussed about the some of the basics and the different types of design methods and the types of stresses involved in the designing of the screw threads. So let us begin with the problem session. So this is the my content of my session. So here we are going to solve some of the examples and question answer session is there, more problem, and finally this assessment, finally the some of the references are there. So now directly we'll move on to the simple problems. So you can take down the problem. Now you can write down. An eye bolt is used to for lifting a load of 80 kilonewton. Find the nominal diameter of the bolt. If the tensile stress is not to exceed 110 megapascal, assume porous threads. So this is the problem as given, and here once again you read out the problem and write down the given data. So he has given an eye bolt is used for lifting a load of 80 kilonewton. That is the tensile load he has given. How much? 80 kilonewton. That is P is equal to 80 kilonewton. That is 80 into 10 raised to 3 Newton. And the nominal, we have to find out the nominal diameter. That is the small d we have to find out. The nominal diameter of the bolt is to calculate. And if the tensile stress is not to exceed 100 megapascal, that is sigma t he has given 110 Newton per mm square. Assume the porous threads. So already in the previous session we have discussed about the bolts are designed based on the considering the tensile load. So he is given by, so here we know that screw threads are subjected to the tensile loading and is given by P is equal to 5/4 dc square into sigma t. So you substitute the value. So in this already we know the value of the tensile load and the sigma t. Substitute the value here. So substitute the value and find out that value for the dc square. Substitute the value here. Substitute it. That is, so dc square is equal to 4 into p divided by pi into sigma t. That is dc square is equal to 4 into p is 80 into 10 raised to 3 divided by pi into sigma t. So calculate it. So you calculate. So let us will check out how much you are getting the value. So you can use you have to compulsorily use the scientific calculator. So anybody, so calculate it. So after the simplification, so here you are getting, so 4 into 80 10 raised to 3 divided by pi into 110. Therefore dc square is equal to 925.87 mm square. Now you can take out find out the dc value of dc. Here it is the square root of 925.87. so here nearly you are getting 30.42. so this is the root or core diameter of the eye bolt. So but assuming the porous thread, that is dc is equal to 0.84 t. Therefore the nominal diameter of the bolt small d, which is equal to dc divided by 0.84. Substitute the value. dc is equal to 30.42 divided by 0.84. So here put the value and find out. Nearly we are getting 36 point how much 23 36.23 mm, or d which is nearly is equal to 37 or m 37. Otherwise, or you can refer the design data book handbook. So in that you open the table number 9.15 page number is there. So in that you find out the value for the 30.42 core dia 30.42. So here 30.42 42. So that is here from the data book nominal diameter you are getting M36. This is the simple problem is there, simple substitution and calculation is there. Okay, now let us move ahead. Next you take on another one. Determine safe tensile load for bolts of M48 and M62. Assume that bolts are not initially stressed and take safe tensile stress as 310 megapascal. So this is the problem he has given. So already in the last session, so we have discussed about the in the theory session, that is the designation of screw threads. That is M48, M62. These are nothing but these are the screw threads are designated by these letters. That is M62, M48. Directly it is, so here given that M48 it is nothing but it is the nominal diameter is 48 mm and M62 means nominal diameter of the bolt is 62 mm. So then the tensile stress he has given 310 megapascal, 310 Newton per mm square. So we have to find out the tensile load. So therefore here let us, there are two cases are here. So first consider the case number 1 for M48. So here the nominal diameter is 48 mm, but we want the root or core dia. So you can use this equation, that is DC is equal to 0.84D. So from that, so you find out the value. So therefore nearly you are getting, that is 48 into 0.84, that is 40.32. 40.32 mm is the root or core dia, or otherwise you can refer the data book also, from the data book taking the standard value. Okay, since this is the bolt 1, so from the data book, so for the value of how much, so this is the nominal diameter is 48. So for the 48, that is root or core dia, you have to take root or core dia. So here it is same. Referring to that table, you can take. So suppose if you are using the chorus series, at that time in the chorus series there is availability of data for the bolt is up to the M39. So there is no alternatives, only you have to use the equation. So since in almost all problems we are considering it as assuming it as a chorus thread only, so for that we are using this value. Therefore already we know that when the bolts are subjected to the tensile loading is given by P is equal to pi by 4 DC square into sigma T. Now you substitute the value here, put the value, and you have to find out the tensile load P. So therefore P is equal to pi by 4 DC square. So that is DC square is equal to 40.32 square into sigma T is already given 310. Now you have to calculate this. So how much you are going to get? So you do it calculation, 40.32 square into 310 into 3.14 divided by 4. So nearly, so you are getting 39,000, that is the 3,95,866.66 Newton. So this is this much amount of the tensile load is acting on that bolt. So otherwise you can keep in the kilonewton form, that is 395.866 kilonewton. So this is the amount of the tensile load is acting on that M48 bolt. Okay, now consider for M62. So here also same, this is equal to 0.84D. so therefore from that, so you find out the value, so nearly, so you are getting 52.08, or otherwise can go to the design data book. In that for the chorus, the bolt chorus series, the bolt, so So up to 39 is restricted. So here you can for the metric series also, so nearly we will get the same value. So for the M62, no, there are no M62 directly. So for the root or core dia 60, okay, okay, almost they are same value we are getting. We have to use this. So therefore already we know that when the bolts are subjected to the tensile loading, P is equal to pi by 4 dc square into sigma T, and substitute the value here. P is equal to pi by 4 dc square 2.04 square into sigma T. Do the simple calculation. So therefore, so nearly here you are getting how much, you can do the calculation. So here, so that is pi into 2.08 square into divided by 4. So here you are getting 6,60,379. 6 lakh, okay, 60,465 Newton. Otherwise you can write it as a 660 kilo Newton. So this much amount of the tensile load is acting on this M62 bolt. So now let us take another problem. An engine cylinder is 300 mm in diameter and steam pressure is 0.7 Newton per mm square. If the cylinder head is held by 12 studs, find the size. Assume safe tensile stress as 28 megapascal. So this is the problem. So as given, once again you read out the problem and you have to write down the given data. An engine cylinder is 300 mm diameter. That is diameter of the cylinder he has given. So that is 300 mm. You can write it as a capital D is equal to 300 mm. And the steam pressure is 0.7 Newton per mm square. The cylinder head is held by 12 number of bolts. That is number of studs are used. That is small n is equal to 12. Assume the safe tensile stress, that is sigma T is equal to 28 megapascal. Okay. So now, so before proceeding further, here we have to find out the what will be the total amount of the tensile load is acting on the engine cylinder, that is head. So that is we have to find out from this. The diameter of the cylinder is 300 mm. Pressure developed by the cylinder is 0.7 Newton per mm square. So from this we have to find out the total amount of the gas load is acting on the cylinder head. Total amount of the gas load or force acting on the cylinder head. So that we have to find out, because already we know that in the last session we have given some of the important definitions and the conversions. In that we have given the definition of the pressure is what? That is force or load acting per unit cross sectional area. It is known as the pressure. It is force per unit cross sectional area is known as the pressure. From that equation we have to find out the amount of load or force acting on the engine cylinder head. So that is nothing but simple, that is the rearranging the term from that basic definition. Therefore the force or load which is equal to area into that pressure. The area of the cylinder is known, that is pi by 4 capital D square. So from that we have to find out the total amount of load acting on the cylinder head. So that is, so we know that force or load is equal to area into pressure. Area is equal to pi by 4 D square into pressure. Pi by 4 300 square into 0.7. So you do the calculation for this. A simple calculation is there. It is pi into 300 square into 0.7 divided by 4. So after the simplification, so the force or the load is acting on the wood is 49,486. Okay. this much amount of the tensile load is acting on the board, cylinder head boards. So now, so here we know that when the boards are subjected to the tensile loading, it is given by the equation, that is P is equal to pi by 4 dc square into sigma T into N. Now you substitute all the values. P is calculated, substitute the value of P, pi by 4 dc square as it is, sigma T is known, and number of bolt is also known. You substitute the value, substituting the value and make the simple calculations. So then we are getting, so that is dc square is equal to 4p divided by n into pi into sigma T. So after the simplification, so here you are getting 188 mm square. Now you find out the value of dc. Therefore value of dc is equal to square root of 188. So here, so you will get 13.7 or 14. Okay, so that is so the value you are getting 14 mm. So this is the root or core dia you are getting. So therefore, assuming the torus thread dc is equal to 0.84 d, so therefore the nominal diameter of the bolt d is equal to dc divided by 0.84, dc divided by 0.84. Therefore substitute the value dc divided by 0.84, dc is equal to, so that is 14 divided by 0.84. So here you are getting 16.66 mm, 16.66 mm or M17. Otherwise you can use the design data book. From the design data book, table number 9.15, that is table number 9.15. so in that, so you open for the 14, for the M, that is 14. So here also we are getting the same, so nearly we will get the same, that is for M18. So this is the value we are getting from the design data book. So now let us move further. Let us take down another one. The cylinder head of a steam engine is subjected to pressure of 1 Newton per mm square. It is held in position by 12 number of bolts. The effective diameter of the cylinder is 300 mm. A soft copper gasket is used to make the joint leak proof. Determine size of the bolt so that stresses in the bolt does not exceed 100 megapascal. This is the problem he has given. So once again you read out the problem and you write the given data. So he has given, so the steam pressure, the pressure of the steam, that is which is producing in the cylinder engine, is 1 Newton per mm square, and it is held in position by 12 number of bolts. Number of bolts is n is equal to 12. The effective diameter of the cylinder capital D is 300 mm he has given, and the allowable, that is the bolts are not initially stressed, and the stress in the bolt does not exceed 100 megapascal, that is tensile stress in the bolt is 100 megapascal or 100 Newton per mm square. So once again, so here also we are proceeding in the same manner. Already here we know that is the force or load which is equal to the cross sectional area into the pressure. Now that is, once again here we are using from the basic definition of the pressure. Pressure is nothing but force per unit cross sectional area. So from that, force is equal to area into pressure. So from that, so that is force into equal to area into pressure. Substituting the values, area is equal to pi by 4 d square, capital D square into pressure, put the value and substitute here. Simple substitution is there. The value pi by 4 300 square, pi by 4 300 square into 1. Okay, substitute and make the simplification, make the simple simplification. Now after that we are getting 70,695. 70,695. So and 695 Newton. So here but we also know that screw threads are subjected to the tensile loading and is given by P is equal to pi by 4 dc square into sigma t into L. Now we substitute the value 70,695, that is the load. So pi by 4 dc square as it is, sigma t is and number of pole. Therefore dc square is equal to 4p divided by n into pi into sigma t, which is equal to 4 into 70,695 divided by 12 into pi into 100. Therefore you are getting dc square is equal to 74.99 mm. 74.99 mm. Therefore you make the calculation, square root of this nearly you are getting 8.66 mm. So but assuming the chorus thread DC is equal to 0.84 D. So therefore the nominal diameter of the bolt D is equal to DC divided by 0.84. Substitute the value 8.66 divided by 0.84, which is equal to 10.30. So otherwise you can write it as a M17, or you can use the design data book. From the design data book 9.15 table. So from that 10.30, so 10.30, so that is also 8.66. So from that, so the nominal diameter of the bolt is 11.966 or M. Okay. This is the about this problem. So here we have solved almost the simple problems. So now we will proceed further. So if you have any doubt related to the problems, you can. Otherwise we will proceed further. Okay. So if you have any questions regarding this, the sum of the problems, whatever we have solved here. So then we will proceed for the sum of the homework assessment we are going to give based on the session. So now we take down the some problems. First one, determine safe tensile load for a bolt of DC is equal to 28 mm and DC is equal to 53 mm. Assume that bolts are not initially stressed and take safe tensile stress as a 180 megapascal. This is number one problem. So here you solve it is very simple problem is there. Otherwise we will give the sum, the hint for the this first one. So already here DC is 28 mm as well as 53 is given. So directly, so you have to find out the, you have directly put in the equation P is equal to pi by 4 DC square into sigma t. Directly you can find out the value of that. Now we take down the second one. An engine cylinder is 240 mm in diameter and the steam pressure is 45 Newton per mm square. If the cylinder head is held by 6 studs, find the size. Assume safe tensile stress as 32 megapascal. So this is one of the, once again the same problem whatever we have solved in this session. We can so I will give the clue or hint for this. Engine cylinder diameter, the capital D is 240 mm he has given. Steam pressure is given 0.45 Newton per mm square is given, and the number of bolts is 6 and sigma t is 32 megapascal is given. So from the diameter and pressure you have to find out the area. From the area into pressure you are getting the total load or force acting on the cylinder. Okay. So from that once again you can use the P is equal to pi by 4 dc square into sigma t into n. So from that equation you can find out the value of dc square, once again assuming the chorus thread and proceed in the same manner. Similarly, we take down the third one. The cylinder head of a steam engine is subjected to a pressure of 1.25 Newton per mm square. It is held in position by means of 8 bolts. The effective diameter of the cylinder is 250 mm. A soft copper gasket is used to make the joint leak proof. Determine the size of the bolt so that stresses in the bolt does not exceed 90 megapascal. Once again it is same similar problem, so we can do it in the same manner. Okay, so here also diameter, cylinder diameter is given, capital D, can write it as 250 mm. Steam pressure is 1.25 is given, n number, that is the number of volts, n is equal to 8, and the stress, tensile stress in the bolt is 90 megapascal as given. So from all these data, so once again you proceed in the same manner. First you have to find out the gas load or pressure, the steam force acting on the cylinder head. So you have to find out force is equal to, that is area into pressure. Therefore finally we can use the equation P is equal to pi by 4 dc square into sigma t into n. Okay, so from that you can find out the dc square. Finally, assuming the chorus thread, dc is equal to 0.84 d, otherwise you can find the nominal diameter, or you can directly use the design data book. From that you can find out the standard dimensions of the board. So these are the some of the homework problems assigned for the student. So in the next session you have to come up with the solution for this. So already given the hints for this, you have to come up with the standard dimensions or solutions for these problems. So now let us move on to some of the multiple choice questions based on this session. So we are discussing here some of the questions. Now let us take, so we will move further. Okay. Question is this: an eye bolt is used for lifting a load of 80 kilonewton. It means 80 kilonewton is there. What does it mean? So that is the option A is P is equal to 80 newton, P is equal to 800 newton, C P is equal to 80,000 newton, and D none of the above. So already we have discussed in the previous session units and conversions. In that we have discussed about what is meant by kilo, what is meant by mega, what is meant by giga and other things. Okay, kilo means so much. Just think it. Okay. Otherwise we will tell that is 80 kilonewton, that is 80 into 10 raised to 3 newton. 80 into 10 raised to 3 newton, it is nothing but 80,000 newton. So therefore the answer for this question is 80,000 newton, that is C. Next you take down another one. Find the value of a given DC. Okay, therefore DC square is equal to 4p by pi into sigma t, that is value he has given 4 into 80 into 10 raised to 3 divided by pi into 110. Okay, calculate it. Simple calculation is there. Simple calculation you do it. So calculate it. So here the correct answer for this DC square is there. DC square is, he has asked for the DC. Square root of that you are getting the DC. So DC square here nearly you are getting 925 point something AD. So therefore square root of that, so we will get 30.42. So therefore the correct answer for this question is option C. Next we take down third one. The cylinder head of the steam engine is subjected to a pressure of 1 Newton per mm square. The effective diameter of the cylinder is 300 mm. Then the total gas load is equal to, what will be the total gas load? So already from the basic definition, so that is the pressure is equal to force per unit cross sectional area. We have to find out the force or the gas load. Therefore force or gas load, which is equal to area into pressure. Area is equal to pi by 4 d square. D is already given 300. That is pi by 4 300 square into 1. So you do calculation. Do it. Okay. So therefore the correct answer for this question is 70,695 Newton. That is option C. Okay. Next you take another one. Last, that is the fourth one is there. That is a bolt of M20 into 2. It means what? Means that option A, diameter is 20 mm. Option B, nominal diameter is 20 mm and pitch of the head is 2 mm. Pitch of the thread is 2 mm. And option C, the nominal diameter is 20 mm with depth of the thread is 2 mm and none of the above. Try it for this question. So already in the theoretical sessions we have discussed about the designation of screw threads. So usually for the porous threads or porous the screw fastener, they are designated as a M20 and it is the M20 into something. So like that, if the designation, the screw designation, if the letter M which is followed by the number, so that indicates the nominal diameter of the bolt. Okay. If further there is no values, numbers or other values are not there, it is understood that, say suppose you consider if there is a M20 only, at that time its meaning is the nominal diameter of that bolt is 20 mm. But here it is into 2 is there, means in another designation is there. So there is the along with the letter M with the number is separated by another into mark, some value is there. So that indicates that the pitch of the thread, they are going to indicate the pitch of the thread. So that is the both these values are separated by the a into mark. So means here M20 into 2. So M20 is nothing but it is the nominal diameter of the bolt and the 2 mm is the what? 2 mm is nothing but it is a pitch of the thread. So to designate the pitch of the thread, these two 20 mm and 2 mm pitch is, they are separated by a into mark. So this is nothing but the correct answer for this question is option B. So that is the screw M20 into 2 is, that is the nominal diameter of the bolt is 20 mm with the pitch of the thread is 2 mm. So don't consider nominal diameter 20 mm with the depth of thread. Depth of thread is different. Depth of thread is different and the pitch of the thread is different. And simply the diameter is 20 mm means, so understood, if there is a only M20 then it may be corrected. Okay. So but here the correct answer for this question is the option B. So in the third also you make the simplifications are there, means simple calculations. So do the calculation. So the intention of assigning these questions is to have a that is the you have to be perfect in these MCQs, because then only you can refer. So in competitive examinations, so this type of question you get. So similarly there are in the designation of screw thread there is another that is grades are there, 7, 8, 9 they are going to give as a grade, that is small, medium and the high grades are there. So medium grade, chorus grade, like that the grades are also come in the designation. So like that, so the tolerance designation is there, tolerance grades are there, and this is the chorus grade, that is the pitches are there. So that is M20 into 2. So like that M25. So M25 into 2.25 or 2. So like that, there are different types of the screw thread designations are there. This is, I think I have covered a lot of things in this session. So further we will in the next session also we will cover some of the problems. So here, so we will go for them. These are the references for this session. So whatever the content covered, so they are based on the referring all these books and almost all problems, even the worked example and as well as homework problems. So whatever we have assigned, they are all taken for reference from the all these textbooks as well as reference books. So these are the reference books. So finally, so once again we will thank you on behalf of all our team, LMS team members, LMS system. Okay, once again thank you for the cooperation and attending this session. Thank you.